Hi everyone, and welcome to Chapter 5. Chapter 5 is going to be starting our long discussion on the trig functions, the trigonometric functions. We will talk about them in Chapters 5 and 6 and 7, I believe, as well as a little bit of, I can't remember, 8. So I know for sure 5, 6, and 7. But before we can start talking about the trig functions, we do need to talk about measuring angles, what we measure angles in, because we're going to introduce something that's not as relatively well known, but it is used more extensively in the science worlds and the mathematics worlds. And that's the unit of an radian. But before we do that, we're going to get some terminology down. When we draw angles, we usually have a starting line, starting ray, and this is going to be referred to as our terminal side. Whoops, I'm sorry. Our initial side. And then what we do is we will go a certain distance and draw another ray. And this, where we end up, that's the terminal side. And then we have our angle in between those. When we go in the counterclockwise direction, that's going to have a positive angle measure. So this one looks like it might be roughly 45 degrees, I'm going to guess. I don't have a protractor here with me to measure it, but it could be that roughly 45 degrees. If we had gone in the clockwise direction, so there's my initial side, and if I go in the clockwise position, that's going to be a negative angle measure. So this one looks like it's about, I'll say, a negative 47 degrees, because it looks a little bit bigger than the other one. Again, initial side and then our terminal side, where we end up. And we are familiar with measurements in degrees. I'm hoping that you guys know a little bit about degrees. For example, you would know that a 90 degree is a straight right angle. That doesn't quite look like 90 degrees. 180 degrees, and so forth and so on. So we measure angles in degrees. We do measure them in the scientific world in radian measure. And the one thing, when we're using radian measure, we do not have a symbol that is attached to it. So if you have an angle that someone tells you it's 7 in size, that means that they're actually talking about radians. If you have the little degree symbol, you need that little symbol there. So if you're measuring things in degrees, you need the little degree symbol. If you're just using radians, it will not have a symbol attached to it. And that will become more apparent as we use them more often. But the definition, first of all, is if we have a circle of radius 1 is drawn, and I'll do my best to do that, with a vertex of an angle at its center, then the measure of this angle in radians is the length of the arc that subtends the angle. That may not make a lot of sense, so I'm going to draw a picture to help us understand what that is. So if I have a circle, okay, so imagine that's a circle, and it's of radius 1. So I'll put a radius of 1 here. So 1 inch, 1 centimeter, whatever, 1 whatevers. And you have an angle. Okay, so I'll call this angle theta. So that is theta. It is the Greek letter theta. We use lots of Greek letters to represent angles. So theta measurement in terms of radians will be whatever this arc length is. So the arc length is going to be the same as the radian measure. So how in the world does that make sense? Well, we're going to get some relationships here. So let's take our circle of radius 1, okay, and I want to know what is the angle measure in radians of 360 degrees. Okay, I might not have written that very correctly, but what I want to know is how many radians is equivalent to 360 degrees. So 360 degrees is if you go all the way around, right? So there's 360 degrees. Now we were told that the radian measure is the same as the arc length measure. So that means the arc length would be that circumference of that circle. And we know that circumference is 2 pi r. But the special case when we're doing radian measure, our radius has to be 1. So that means our radian measure is the same as our circumference, which is 2 pi. So that is the same as 360 degrees. Okay, so knowing that all the way around is 2 pi, we could get the equivalent for 180 degrees is equivalent to, well, 180 degrees is half of the circle, so half of this is equivalent to pi radians. If you want that labeling on there to help us. We could do 90 degrees. Would be half of the half, so half of pi, so pi over 2 radians. So 90 degrees is pi over 2. Okay, so we can use these facts, and we like to use in particular the 180 is pi, to do conversions. So if we want to convert from something in radian measure to degree measure, or degree measure to radian measure. So let's say I have a 30 degree, and I want to convert it to radian measure. We're going to multiply by a unit conversion fraction. We want the degrees on top to cancel, so we'll put that 180 degrees on the bottom, and we'll have pi on top, because pi and 180 is just an ugly way of writing the number 1. So 30 degrees in terms of radians, if I do my reducing here, turns into pi over 6. So 30 degrees is the same as a pi over 6. 45 degrees, again, we'll multiply by that pi over 180, is pi over 4. Or I know it's half of my half of my half. Or a quarter of my 180. Let's do another common one that we will use all the time. Is our 60. And you'll notice 60 does go into the 180. That gives me pi over 3. Another way to get there is 30 to 60 is 2 30s. So if I multiply this by 2, that also gives me the pi over 3. So we have these three we will spend lots and lots of times with all over the place. Let's just do another one. Let's go 280 degrees. Again, we will multiply by our pi over 180. And we will see that that is, let's see here, doing some reducing. We like to leave pi in there. That gives me 14 over 9. So 14 pi over 9. 270 is not an angle I know a whole lot about, but that's okay. And hopefully I did that correctly. Divided both by 20. I think so. We can go the other way as well. Let's say we have 3 pi over 8 as a radian measurement, and we want to turn it into degrees. Because maybe we're going to be talking to someone who is not mathematically knowledgeable. And for now, you guys will be doing a lot of this, converting them back and forth to get comfortable with the radian measurements. So we will take that 3 pi over 8, and this time we're going to be multiplying by, sorry about that, the 180 degrees over pi. A lot of our radian measures do have pi in them, not all. And let's see. There's a 4 in both of those. I wonder if there's 8. I don't think so. No. Oops. That turns into 135 over 2 degrees, if I did that correctly. Which is 67.5 degrees. Okay. We could also have 1 radian. Ooh. So if I had that circle back up on the top here, and if I went 1 unit around, where would that turn out to be? Well, again, we will be multiplying by the 180 degrees over pi. And I'm actually going to use pi in there because it does not cancel. So if I take 180 and I divide it by my pi using my pi button, I get that this is about 57 point, I'm going to just go to the nearest tenth, 3 degrees. Approximately 57.3 degrees. Okay. This sounds like a good place to kind of stop. Practice converting degrees into radians or radians into degrees so that you do feel comfortable with that pi being 180 or 180 being pi. We're going to come back with some more practice and going a little bit further in this section as well.